Before embarking on the tools and techniques in statistics, we need to have a common understanding of some key terms. The first set of key terms is population versus sample. A population is the entire set or collection of people or objects of interest. For example, the population could be 100% of the households in Singapore, or it could be all the cars in Singapore, or it could be 100% of the students in all the polytechnics. A sample, on the other hand, is just a subset or a portion of the whole population. So a sample is a smaller set than the population. For example, a sample could be just 30% of the households in Singapore, or 10% of the cars in Singapore. When collecting data, we often conduct surveys. Surveys can be categorized into census versus sampling. If every member of the population is surveyed, then it is called a census. On the other hand, if only a sample out of the whole population is selected for the survey, then that's called sampling. For example, if 100% of the households in Singapore are surveyed, then that's called a census. But if only a sample of 30% of households are surveyed, then that's called a sampling. Another set of key terms that you have to know is parameter versus statistics. A parameter is a numerical characteristic of a population, such as population mean, or more commonly known as the average, or the population proportion or percentage. A statistics is a numerical characteristic of a sample, such as sample mean or sample proportion. The big difference between them is that a parameter is derived from a population, while a statistics is derived from a sample. Chances are, a parameter is usually the actual value we set out to find, but it will remain unknown to us due to practical reasons. For example, we may want to know the actual average household size of the population, but conducting a census for the entire population might be too expensive and time-consuming. Hence, it will likely to remain as an unknown value. Instead, we can select a sample and calculate the sample statistics. For example, if we select a sample of 30% of the households in Singapore and compute the average household size, that becomes a lot more manageable. And we can then use this sample statistics to estimate the population parameter. Parameter and statistics give us a numerical summary about the data. But what data are we going to capture to begin with? The characteristic of interest for our data collection is called a variable. Variables can be of two types, qualitative or quantitative. Qualitative variables are non-numerical in nature. The people or objects may come from different categories. For example, the variable gender may be categorized as male or female. The colors of cars may be red, blue, or green. Quantitative variables, on the other hand, can be measured and reported numerically, such as age, weight, and height. Quantitative variables can be divided into two types, discrete and continuous. Discrete variables arise from counting. It can take on only certain values within an interval and tend to have gaps in between. For example, the data for age may be captured in whole numbers, such as 10, 11, or 12 years old, or it may be captured in gaps of 0.5, such as 2 years old, 2.5 years old, 3 years old, etc. On the other hand, continuous variables arise from measuring. It can take on any values within an interval. For example, height, weight, volume, and temperature are usually measured in continuous decimal numbers, especially with modern digital equipments. As for qualitative variables, the types and categories are implicitly discrete in nature. Are these qualitative or quantitative variables? If it is quantitative, is it discrete or continuous? The number of durians sold can be counted one by one, so that's discrete. The types of durians are classified into different categories, so that's qualitative. The time for transporting durians can be measured and could be any duration with no gaps in between, so that's continuous. The amount of rainfall can be measured and could be any volume with no gaps in between, so that's continuous. The types of places that sell durians can be classified into different categories, so that's qualitative. The monthly salary of durian sellers can be measured. Assuming their salaries are quoted in dollars and not cents, then that's discrete. The daily temperature in June can be measured and could be any temperature with no gaps in between, so that's continuous.